What are parallel lines? You should know what parallel lines are. Somebody tell me what parallel lines are. Well,
two lines that going like together.
They never
touch.
Good. We'll start with that for now. We'll add something to that later. But I like Clover's example. We've got two lines that never touch. So here's my parallel lines. Are you with me? We'll call that line A and line B. We're going to cut them with a third line called the transversal, like this. We'll call the transversal line C. So you might want to put a little note here. This line is the transversal. It's a big word. Transverse means you go across something. If I transverse the United States, I'm going all the way across the United States. Big word. All right, now look at what happens when we do this. When we have two parallel lines that are cut by a transversal, a lot of little angles start to pop up. How many angles are there? There's 4 up here. There's 8. Thank you, Autumn. So I'm going to number them. 1, 2, 3, 4, 5, 6, 7, and 8. When we have parallel lines cut by a transversal, it forms 8 angles. Now, something interesting happens with these 8 angles. All right, but before we get to that, let's talk about this. What if I have a straight line and I put a line segment here? How many angles does a straight line make? 2. How many degrees do the 2 angles in the straight line add up to? Do we know this? Nope. A full circle is 360 degrees. So what would the top 2 be? Say it again, Brady. 180. A straight line always adds up to 180 degrees. So, let's look at the 180 degrees. What if I tell you angle 1 is like 100 degrees? How could you figure out how many degrees angle 2 is?
Subtract 180.
I don't hear anybody. Clover, I hear you.
Subtract 180.
Sure, 180 minus the 100. How many degrees would be left for angle 2? 80. Okay. Keep that in mind as we go through this transversal, because if you notice, isn't this a straight line?
Yes.
Don't these 2 angles have to add up to 180?
Yes.
If I look at it this way, isn't this a straight line?
Yes.
Don't these 2 angles have to add up to 180?
Yes.
Here's another straight line. Don't these 2 angles have to add up to 180?
Yes.
Don't these 2 angles have to add up to 180?
Yes.
Don't these 2 angles have to add up to 180?
Yes.
There's a whole bunch of angles that have to add up to
180.
180 degrees. Are you with me? All right, so let's start. What if I tell you just one angle? You can immediately start finding the other 7, like this. Let's say angle 1 is 110 degrees. I'm going to give you one angle, that's it. Your job is to find the other 7. All right, somebody tell me how many degrees this angle right next to it would have to be. If this angle's 110, how many would that be? Emma?
70.
How do you know?
Equals 180.
Do y'all agree with Emma that these 2 angles have to be 180?
Yeah.
If this is 110, couldn't we do 180 minus 110?
Yes.
And we would get 70, exactly what Emma said? Sweet. All right, if this is 70, how much is angle 3? Somebody besides Emma or Clover. Autumn, you've already helped me too. How many degrees would angle 3 have to be? Haley. Kaylee, I mean.
120?
No, not 120. 120 plus 70 would be 190. I need it to equal 180.
110.
110. Are y'all with it? Now look right here. Don't these two angles make another straight line? How many degrees are there in angle 4, Langston? 70. Are you with me? So notice, if this is 110, then this one has to add up to 180, which would be 70. Then these two have to add up to 180, which would, this one would be 110. This one would also be 70. Notice, how many angles are there? There's 4. How many different angles are there? There's only 2 different angles. Are you with it? All right. If this one's 110, what do you think this one is? Isaiah?
Would it be 110?
Yeah. Doesn't it look the exact same size as that one?
Yes.
Yes, it is the exact same size. Because we have parallel lines cut by a transversal. How much is this one? 70. This one?
110.
This one?
70.
Okay, so the main thing I want you to notice first of all is when we have parallel lines cut by a transversal, there's really only 2 angles in the whole problem. It's either going to be 110 on the big one or 70 on the little one. And you can almost look at the size of the angle and predict which one it's going to be. Big one, 110. Little one, 70. Big one, 110. Little one, 70. All the way through the whole stinking problem. Are you with me?
Yes, sir.
Good. All right. Now we have names for some of these angles. So I'm going to take the numbers out because that's kind of distracting. Leave them in on yours. And we're going to put some definitions up here. We'll put them over there. Let's start with alternate exterior angles. Okay, we'll give a definition of those. Now, before we get to that definition, let's talk about what are interior versus exterior angles. Do you see the 2 parallel lines?
Yeah.
Everything inside the 2 parallel lines are interior angles. So that would be 3, 4, 5, and 6. They're all interior angles. Exterior angles are the ones outside the parallel lines. 1, 2, 7, and 8. Exterior. All right. If I alternate something, doesn't that mean one over here and one over there? Alternate?
Yes.
So, let's talk about angle 1. We need another exterior angle that is the alternate of it. What angle do you think would be the alternate exterior of number 1? Give me a number. Summer, take a guess. I need an angle that is alternate exterior of angle 1. Take a guess. You don't know which one. I haven't given you the definition yet. Take a gamble. Put your hand down. Summer's got it. She can tell me a number.
60?
What?
60?
60. You got 1, 2, 3, 4, 5, 6, 7, or 8 to choose from. We haven't got to angle 60 yet. That's coming in a long time. Okay. The alternate exterior of angle 1. Take a guess.
2.
2? Now that's not a bad guess. It is on the exterior, but I'm going to tell you this. It needs to be on the alternate side. So Summer, angle 2 is on the same side of the parallel line. So don't pick 2. Give me another number you think would be the alternate exterior. 4 is on the interior. Don't pick 4.
7.
7 is on the same side as number 1. There it is. 8 would be the alternate exterior. So let me give you the definition. It's on the opposite side of the parallel lines. And for parallel lines, I'm going to draw these little 2 slashes. I'm not writing out the word parallel lines every time. Opposite side of the parallel lines. And I'm going to tell you this. it must be the same exact size. Angle 1 and angle 8 are both big ones. Are you with me? So let's put a little note here. It must be the same size. And let's put a note. Angle 1 and angle 8 are alternate exterior. There's another pair of alternate exterior. What's the other pair of alternate exterior? Andrew?
2 and 7.
2 and 7, my man, paying attention. They're the same size, they're on the exterior, and they're on the opposite side of the parallel lines. Are you with it? So I agree with Andrew, angle 2 and angle 7. Any questions on alternate exterior? I'll kind of highlight them. Angle 1, angle 8, those are exterior alternate. Angle 2, I'm going to put 2 lines. Angle 7, I'm going to put 2 lines. Those are the opposite sides of the parallel lines, and they are the exact same size. Little one, big one, big one. Question so far? What if we did alternate interior angles? All right, let's randomly pick a person. No, you've already helped me. You're done. Thank you. You've already helped me. Put your hand down. I'm picking Aiden. Angle 4 is on the interior. Do you agree? Yes or no? Tell me the alternate interior angle of angle 4. Take a guess. Very nice. Isn't 6 also on the interior?
Yes.
And is it on the opposite side?
Yes.
Yes. Is it the same size?
Yes. No.
You,
No.
Yes. Yes.
yeah, that's a little one. That's a little one. There's a big one, big one. Little, little. They're going to be the same size. So I agree with Aiden. I'm going to put 3 bars here. 4 and 6 are the same size, or alternate interior. So they're on the opposite side of the transversal. And they must be the same size. So, ooh, I didn't finish the... So Aiden gave us the first pair, 4 and 6. Angle 4 and angle 6. What's the other pair? Nola.
Oh, I have a question. Why is 4 like before 3? That is 1, 2, 3, 4.
1, 2, 3, 4. I can number them any direction I want.
Oh, shoot.
On the homework, it might be 3, 4.
Um,
Now, Nola, tell me the other pair of alternate interior angles.
3 and 5.
3 and 5. Very nice. 3 and 5 are the same size, and I'm going to put a little mark like that on there to show you that those two are the same. 3 and 5. All right, questions so far? Yes?
How do you know if they're the same size?
We already went through the whole problem. If this was 110, that's 70. That's 110, that's 70.
Okay.
Remember, that's the first thing we did. Because these two make 180 degrees. So if this one's 110, that one's going to be 70. If this one's 70, that one's going to be 110. They're all straight lines. Straight lines have to add up to 180. If I give you one of them, you can immediately tell me the other 7. Okay. All right, good question. Any others? All right, one more definition. Let's talk about corresponding angles. I'm going to take all this stuff off. And let's just draw a new one. It's getting too cluttered. Parallel lines cut by the transversal. Let's go 1, 2. Oh, look here, Nola. Does that feel better now?
Yes.
Okay. 5, 6, 7, 8. I can number them any way I want. Okay. Now it is up to Nola's speed. She likes this better. Okay. Let's talk about corresponding angles. Corresponding angles. I'm going to give you the definition, and then I'm going to let you tell me which two would be corresponding. They are the same size and on the same side of the transversal. So I'll give you a second to write that. Square your hands up before you're done. Can't hold the questions. Oh, they. All right, let's go with Zach. Tell me what angle would be the corresponding angle to angle 1. There's only one correct answer. It's on the same side of the transversal, and it has to be the same size as angle 1. So look for a big angle, because 1 is the big angle, on the same side of the transversal.
7?
7 is little
No,
angle.
it would be 8 then.
8 is on the opposite side of the transversal. What angle is the same size as 1 and on the same side of the transversal?
I don't know.
There's only one left. Well, hang on. What side is 1 on?
The
Left or right?
left side.
Okay, you got 3, 5, 7 to choose from. Those are the only 3 on the same side as 1. You already picked 7. We said no. You picked 8. 8's on the wrong side. Which other number is the same size as 1 and on the same side?
3.
3 is the little angle. 1 is the big angle. Look at the size of the angles. It's the exact same size. There's only one more you haven't called yet.
5.
5 is it. Boom. Do you notice that 5 is the big angle, Zach? 1 is also the big angle. Don't pick the little angle or the little angle. It's got to be the same size, and it's got to be on the same side. 1 and 5 are corresponding angles. All right, there's a bunch more. Let's go with Perla. Give me another pair of corresponding angles.
2.
2 and
6.
good. I'm going to put a check mark by 2 and 6 so that we know they're different. They're the same size and they're on the same side of the transversal. Are you with it? If I say same side as the transversal, they both have to be on the right or they both have to be on the left. All right, 2 and 6 will work. There's some more. Give me another pair. Edison. 3 and 7. Yes, I agree. 3 and 7 are the same exact size and they're on the same side. Good. We'll do a box around them. 3 and 7. And there's only one more pair. Tell me the last pair. Gabby. 4 and 8. Let's do a palm tree next to, or just a tree next to 4 and 8. All right, are there any questions? The good news is we're done with the vocabulary now. Okay, this lesson has a ton of vocabulary. Now we're actually ready to solve some problems. All right, so let's say they give me parallel lines. Ooh, I'm going to mess y'all up. What if I put the parallel lines this way? Does it change anything? No. And the transversal can go this way. All right, I'm going to number them. 1, 2, 3, 4, 5, 6, 7, 8. What if on the homework they tell me angle 8 is 120 degrees? We know that this big angle here is 120. From that point, you should be able to tell me any of the other angles. Any one I want. All right, like angle 1. Addison, how big is angle 1? Angle 1, how many degrees is it? 120. Y'all agree with Addison? Isn't this the big one? Isn't that the big one? Addison is correct. That is alternate exterior angles. And in the notes it said they had to be the same size. You're right. It is 120. All right. How big is angle 2? Bella. Angle 2. How did you get 60? You're right, by the way. Do y'all agree with Bella that 120 and 60 add up to 180?
Yes.
Good. Now that we got those two, how big is angle 3? Who is not helping that? Brady. They're the same size? I thought these two had to add it. There we go. Pay attention. If that one's the big one, this is the little one. It's got to be 60. All right. How big is number 4, Isaiah? 120. Now we can rock and roll. How big is angle 6? Look carefully. Bailey. Yeah, it's the little one. It's 60. Good. And it has to add up to 180 with 120, doesn't it? Good. Emma, how big is 7? 60. And how big is number 5? Who has not answered yet? I think everybody has. Andrew.
120.
120. All right. Are there any questions about how parallel lines cut by transversals work? All right. One more example and then I'm done. What if we take out the problem and they do this to me? Angle 8 is 5x and angle 6 is x plus 60. Does anybody have any thoughts? They start putting letters in there, dang it. 5x is angle 8, and angle 6 is x plus 60. What do we know about angle 6 and 8? We only know one thing. What do we know? Anybody's back open again. Langston.
The angles of it.
What about them? Clover, can you help him?
They're different.
They are different. We do know that, yes. What else? We need more than that, though.
They're all like equal 180.
That a girl. Fireworks goes off. That's what I needed to know. Do y'all agree with Nola that these two angles make a straight line? Hello?
Yes.
Didn't we already say two angles that make a straight line have to add up to?
180.
What she said? So watch this. Can't I take this angle, which is 5x, add it to this angle, which is x plus 60, and doesn't that have to be equal to 180 degrees?
Yes.
Now, what do we have? We have an equation. Can't we solve any equation in math?
Yes.
All right, what do we need to do here?
Add them.
Add them. What's 5x plus one more x? 6x plus 60 equals 180. What do we do now? I'm going to draw a line here. How can we figure out what x is? What number do we need to get rid of? Perla.
You guys subtract 60.
Good. Get rid of any number that is not next to x. Subtract 60. Boom, boom. So now we have 6x equals 120. Ooh, we're almost done. How do I get rid of the 6? Because we want to know what x is. Gabby, divide by 6. And I'm running out of room. So what is 120 divided by 6? Calculator time.
60.
Try again. You might want to use a calculator. Emma, 20. So x turns out to be 20. Now, we are not done. 20 is not the answer to any of these problems. How big is angle 6? Doesn't angle 6 say it's x plus 60 more? What number does x need to be? 20. So how big is angle 6? 80. Because you got to plug in 20 right here and add it to 60. Angle 6 is 80 degrees. Are y'all with it? If that's 80, how big is this one? 100. Because 5 times 20 is 100. Or couldn't you have done 180 minus 80 to get 100 as well? All right. Everybody go. Everybody go. Okay, the notes are finally done. All right.